All right, you mathematical animals, let's talk about the unit circle. So this is just going to be an introduction today. We're not completing a full unit circle. If we were in class, we would have a good discussion about what it means to draw an angle on an XY axis. So we're literally going to have that discussion just in my notes form here. And then we'll complete a unit circle next week. So we're just kind of getting used to the idea this week, understanding some vocab like terminal side and reference angle and things like that. So again, if you haven't printed your notes, make sure you do that first so that you have them in front of you while we talk about all of these things. So what we're going to do is no longer just draw free range angles. We can draw angles anywhere on any surface, right? But we're not going to do that now. We're going to stick to drawing angles inside of an XY axis, coordinate axis, all right? And so when we do that, we want to position them very carefully. And we can draw 30-degree angles, 60-degree angles. You probably remember dealing with a protractor. Remember those half circle-like things, a protractor where you can create a nice perfect angle measure of let's say like a 60-degree angle. Well, we're going to do that same thing, only like I said, in an XY axis. What's important is that the vertex of our angle is always on the origin. Your initial side, so the side, so imagine, you take an angle. So if we let me do this right. If I want to create an angle where I open up my hands, the one that didn't move, that's my initial side, right? So in this case, we always start our initial side on the positive x-axis. Then we open up our angle however far we want, and then where it stops, that is what we call our terminal side. So this is just some vocab introduction for you. So the terminal side, it can be in any quadrant. So we can open it just a few degrees, we can open it a whole lot of degrees. What I want you to think about is how many degrees will I have if I go all the way around back to my initial side? Well, that should be 360 degrees, right? We completed a full circle. What if I open it up exactly halfway? Well, you guys should recognize that as a straight angle from geometry or math 2. And that would be 180 degrees, right? And then there's anything in between the 0 to 180 or 180 to 360. We have a whole lot of angles here that would help us complete that whole circle, right? So you can imagine we can draw any angle we want to in the coordinate axis. Then we have what's called a reference angle. So the reference angle, once I've drawn my angle and I stop, I put my terminal side wherever we decide to put that, the distance in degrees, the distance from the terminal side to the closest x-axis will be the reference angle. So we're going to do a bunch of examples together. I just want to introduce you to the terms and the ideas at this point. So just remember, we're going to be drawing angles, as you can see in my examples, inside a coordinate axis, and we want to be able to find that reference angle. And we're also going to talk about how we can rename this angle. So when we open up from our initial side, when we open it up and we have our terminal side, as long as we're going counterclockwise, that is a positive angle. So if I were to just open it up here, it would just be a positive 30-degree, let's say, angle. Now, if I open it the other direction, that is a negative angle. So when I go clockwise around my XY axis, I'm going negative degrees. And when I go counterclockwise, I'm going positive degrees. That might be something you want to write down in your margin. You could pause here. So remember, counterclockwise is positive degrees, clockwise is negative degrees. So I want to go ahead and take a look at the examples so you can kind of start putting numbers to these ideas. All right, so I've got an 120-degree angle that I've drawn here. So there's my terminal side. Oftentimes we don't even see the initial side. We just know that it's always on the x-axis, the positive side. So I know that I've opened up my angle to 120 degrees, and my reference angle will often be the first question. So what is the reference angle? Well, that would be the portion from my terminal side to the closest x-axis. So that's this part right here. So this is the reference angle. Well, I know that if I open up all the way to this x-axis, how many degrees would I have gone? Well, I know that would be 180, right? So I stopped at 120. What is the difference between this 120 and this 180? Well, that would be another 60 degrees. So that means that my reference angle is 60 degrees. So it's how many degrees are between my terminal side and the closest x-axis. So that would be 60 degrees. Now a negative angle. So what I want for you to find for this is from your initial side, I want to end up in the same terminal spot, but I want to go the negative degree direction. So when I went positive 120, I landed here. How can I land in that same spot going my negative direction? Well, what do we know about making one whole lap around the circle? We know that that would be 360 degrees, right? So if the angle is 120 going this direction, then I know it's 120 less from the 360 going the other direction, if that makes sense. Also, you know that if I were to go all the way to here, I'm going 180 plus another 60. So that's another way you could look at it. So that would be 240. So negative 240 degrees would land me in the exact same spot. And then they're going to ask you for another positive angle that is greater than 360. So what this means is that if I were to open up to 120 degrees, this is what the angle looks like. Couldn't I also, starting here on my initial side, go one whole lap around, just think of a clock, right? And then 120 degrees, and I would still land at the same spot, right? So remember, you can make your minute hand on a clock go, around and around and around, and then you can tell it where to land. So in this case, I go 360 plus another 120, so that's 480. So that would be 480 degrees. You could keep going. You could add another 360 and another 360. So there's an infinite number of possible angles that are greater than 360 to land in the same spot. There's also an infinite number of negative angles, right? Because you could go negative 360 and a negative 240, and then another negative 360. So just remember that there are multiple correct answers. When you're doing Pearson, however, just go one lap around 360 so that you don't end up getting it wrong just because they haven't actually put all those other options in there. All right, let's try another one. I'm going to move it up just a bit. All right, so 240 degrees is our initial angle here. So initial side, we opened it up to 240. I want to find my reference angle first. Remember, we want to find the distance from the terminal side to the closest x-axis. Be careful here, because I've seen students, a lot of times they want to go to just the nearest axis in general. Don't do that. We don't want to know how far it is from the y-axis. We want to know how far it is from the x-axis. So in that case, it's just this distance here. All right, so if I went 240 degrees, I passed 180, didn't I? How far past 180 did I go? Well, it turns out I went 60 degrees because 240 minus 180 is 60. So again, my reference angle happens to be 60. And all this is asking for is how far is it from the x-axis. So that's what they can be the same reference angle for these two examples, even though the initial angles in standard form here are different. Okay, a negative angle. How far would I have to go in the negative direction in order to get to this same terminal side? So you can look here, we want to go this direction, right, and land in the same spot. So we know that you could do this a few different ways. You could take 360 minus your 240, and that's your difference, right? That's probably the easiest way. A lot of you are probably looking at this and you can just mentally figure out where you would land, which is great. But sometimes it's easier so in this case, I want 240 minus 360 because I want my answer to be negative, right? And so we know that that is negative 120. So that's a negative 120 degree angle. And then another positive angle. So just like I said before, you're literally going to take your angle and you're going to add 360 to it because we're just going to add a lap around. Kind of seems silly, I know, but it allows us to start talking about sine and cosine functions down the road in a couple weeks, and you'll understand why, because it's cyclical, and we want to look at the first 360 degree rotation and then the next 360 degree rotation. So in this case, I'm going to take 360 plus 240, and that'll give me 600, right? So that's a 600 degree angle as well. So I know that if just like on a clock, if I take my initial side and I open it up 600 degrees, I will still land in the same terminal spot. Okay, now I'm gonna If you need to write anything down here, pause and do that, because I'm going to go ahead and move this sheet. All right, and now let's take a look at one more example, and then I just have a quick conversion to give you, and then we'll be done. Okay, so again, I've got my initial side and my terminal side. What is different with this problem? Well, this time I'm giving you a negative angle to start. I'm telling you that we opened up 15 degrees in the negative direction. And so my initial standard position angle is negative. So what is my reference angle? How far is this terminal side from the closest x-axis? Well, it's 15 degrees, right? So what do you notice about reference angles? No matter what we give you, our reference angle should always be positive, right? Because we just want to know the degree difference between the terminal side and the x-axis. We don't care if it's above, below, over here, it doesn't matter. So your reference angle will be positive, and it is 15 degrees. Now, what would the positive angle be to land in the same terminal position? So remember, I want to go all the way around and get to the same spot. Well, I'm 15 degrees short of making one complete circle. So if you take 360 and you subtract your 15, you get 345. So in this case, we have a 345 degree angle. What if I asked you to give me another positive angle greater than 360? Well, we would just take 345 and add 360, right? And that would give us another positive angle. What about another negative angle? Well, you could add 360 going this way and then add another negative 15. So that would be negative 375. So hopefully you're getting the idea how you can name this particular angle in so many different ways, right? Positive, negative, you can give it its reference angle. So let's talk about conversion. So we are going to convert just like we do between, feet and meters or ounces and teaspoons. There's two ways that we can name angles, and the one that we're most familiar with is degrees. We've talked about angles in degree form for years, but we can also talk about them in radian form. So a radian is just another type of measurement. So I'm going to show you a few here. So these are just some standards to have memorized, and in fact, you're actually going to have the entire circle memorized by the time we're done with this. But you'll see here that this is a 90 degree angle, right? As long as we're still starting at our positive x-axis, this is 90. We also call that pi over 2. And the one that we base all of our conversions off of is the 180 degree angle. So that would be a half circle. That is pi radians. And you can label radians as RADS, rads. So this is where I would, if we were in class, make all my rad jokes, but sadly I can't. All right, 30 degrees, we call that pi over 6. So you might be wondering how I'm getting these other values. Well, here's our conversions right here. You can literally just use this as your little formula. So if you want to convert from degree to radian, you literally multiply your degree value by pi over 180 and reduce it. If you want to go from radian to degree, you literally multiply your radian value by 180 over pi and reduce it. We try to keep things in fraction form if possible, but you will notice there will be times on Pearson or on a test where they will let you use your calculator and you can just simply turn it into a decimal. Just know that most often when we're talking about radians, we want to see the little pi symbol in our answer, right? Because we want the pi there. If we're talking about degrees, we don't want a pi symbol. So that's why it's on the bottom here. We want to get rid of the pi. We want to divide it out. So let's do a couple examples together. You'll see how easy this is. So I'd like to convert 210 degrees to a radian value. So if I'm going from degree to radian, I multiply it by pi over 180. So I literally just take 210 and I multiply it by pi over 180. So if you multiply this together, you're literally multiplying straight across the top and straight across the bottom. Well, what's underneath 210? Just a 1, right? So this becomes 210 pi over 180. Now, I don't want you putting that into your calculator and getting a decimal. I just want you to reduce the fraction. Keep your pi symbol where it is. It doesn't really affect anything at the moment. We know right away I can divide both top and bottom by 10, can't I? Because they both end in 0. So that's 21 pi over 18. And hopefully you recognize these are also both divisible by 3's, right? So 21 divided by 3 is 7, and 18 divided by 3 is 6. So 7 pi over 6 is going to be our radian value, and that's all you have to do. So 330, same thing, times pi over 180, multiply straight across the top and straight across the bottom, and reduce. So 33 over 18, I did that by dividing by 10. These are both divisible by 3, and so 33 divided by 3 is 11, and 18 divided by 3 is 6. If you look just to the right, I'm asking you to convert this radian back to degree. Well, we really don't have to now because we already know the answer. Let's do this one though. I do want to convert this radian to degree. So if you look here from radian to degree, now we multiply by the reciprocal, right? And think about it for a minute. If I want to go to degree, I want to get rid of the pi because I don't want a pi symbol in my degree value. So that means I got to have pi on the bottom so that when I take care of my multiplication, they actually cancel out. So if you multiply straight across the top and straight across the bottom, you could start reducing right now if you want to. 3 goes into 180 60 times, right? So 2 times 60 is 120 degrees. So if you're confused with what I did there, you can simply go ahead and multiply straight across the top, straight across the bottom, and then reduce whatever you see. Don't be afraid, you can use your calculators, but just don't give me a decimal answer. That's not gonna help you. And I'm gonna go ahead and take care of 11 pi over 6, just because I want you to see the process. So we're gonna multiply by 180 over pi. This time I'll do it without reducing as I go. All right, so 11 pi times 180, I'm actually gonna need to, 11 times 180 is 1980. So that's 1980 pi over 6 pi, right? So I took care of the multiplication all the way across. Now the pi's cancel, don't they? And 1980, let's see if it's divisible by 6, and it sure is. It is 330 degrees. All right. Hopefully that helps you guys. So get started on the Pearson assignment. It's I think it's about 12 questions, and it really is just simply these questions that we just did today. We will get into more unit circle stuff next week. Have a great week, guys.